planned this academic event to take place in the course of the international student week Ilmenau, to give you the opportunity to experience the university culture of the TU Ilmenau. So, dear students and members of the Technische Universität Ilmenau, please allow me to carry on with the presentation. When investigating the internet for dies academicus, it is said that this special day there are no regular seminars and lectures. Well, for all students, and I think for all teachers as well, this might at first seem a good reason for joy initially. But the sentence continues saying that all members of the university, students and teachers, are kindly asked to participate in a lecture program especially prepared for this event. So, to leave no room for doubt what the university expects its students to do, we will not deprive you of the final sentence of the quoted definition. Therefore, it says, dies academicus is no day off. And that this sentence has got an exclamation mark at its end. Of course, this does not mean that dies academicus is obeying fortune. You already felt it when listening to the merry festive music of the chamber choir of our university, presenting music by Johann Michel and music by Ernst Posch. We are particularly looking forward to the lecture of one of the last, as I would call him, universal scholars of our day. And after his lecture, you're invited to discuss his topics with himself, so please don't leave this room before you're asked at least one question. Before this lecture, the president of the university, Professor Peter Scharf, would like to welcome you personally.
Gens, Professor Sommer, Somanske, Lord Mayor Tischer, dear guests from the National Physical Laboratory Middle Essex, this is Andrew Yakut and Trevor Esward, dear colleagues, dear organizers, especially organizers of history, dear Dr. Kapp, and especially dear participants of ISLI 2013. It's a great pleasure for me to see you here participating in this special event during ISLI week, and this is the dies academicus, as you heard already from Mr. Katzella. It is our tradition always to contribute a lecture to this week. A lecture being held by a very prominent person, a famous person. Very often this was a politician, for example, our former Chancellor Helmut Schmidt, or Matthias Platzek, he's the leader of one of the countries in Germany, in Hamburg. And so on and so on. Also, for example, Professor Heisenberg, he's the son of the Nobel Prize winner Heisenberg, he was here giving us a lecture. And today, it's a very great pleasure for me to welcome Professor Fischmann from Vienna. I think it is a man whose contributions to science, but not only to science, but also to society, are very, very high. And so, I appreciate very much to have you here, Professor Fischmann. Welcome to the Ilmenau University.
Haben Sie früher mal gemacht. Zur Ostzeiten haben Sie geklopft.
Professor Fischmann will be especially introduced by Mr. Petzella after my short speech. But I can say he has written so many books, and books which are not only interesting for a physicist, especially theoretical physicists. Also, he has written a lot of books in theoretical physics. But I must say, as a chemist, I have some difficulties to read them fluently. I have to look. But he has written a lot of books dealing with men, with society, with our universe, with time, and so on and so on. So he's very famous also in this, and I know that he is a very great expert in music also. He's a fan of our famous composer Beethoven, and it was, for me, it was extremely astonishing to listen to a lecture given by Professor Pichmann dealing with the sonate, the sonate format, and especially with the sonate format in Beethoven's work. So it was extremely nice, and I think this is not so often that a scientist, based on theoretical physics, is able to be an expert also in these fields, all these fields. So he's a universally educated person, and I think I admire this very much. I do not want to say too much words. Just let me say that you are all welcome to our university, to Germany, to Thuringia, and again I can say that this ISGI event for our university is a very big event. It is a component of our strategy of internationalization, of having peace altogether, of being free from violence, and for being open to other cultures, to other people from all over the world. Welcome to Ilmenau. Thank you.
Ladies and gentlemen, I'm proud to announce now our testimonial lecture given by, as I called him, one of the last universal scholars of our time. Professor Schaaf told you his name. Herbert Pichmann is Professor Emeritus for Theoretical Physics at the Vienna University. His antecessor was the famous Erwin Schrödinger, and I guess you heard this name as well once before. Calling him an absolute expert in theoretical physics and quantum mechanics, one would do him wrong. This would be an oversimplification. Professor Pichmann, born in 1939, is also an expert in, as we heard, classical music, philosophy of science, holistic medicine, didactics in philosophy. And Professor Herbert Pichmann is also one of the most charismatic orators of our day. For many decades, with his lectures, he has been inspiring thousands of listeners. And after his lecture, Liberté, Égalité, Fraternité, in a mechanistically dominated world, I'm very much convinced you will be part of these enthusiastic and inspired listeners. If you please stand.
Ladies and gentlemen, thank you very much for your very warm introduction. I will have difficulties to fulfill all the expectations you have raised, but I'll try to do my best. Let me right in the beginning jump into the topic which I want to develop today. I think you will all agree with me that we are living in an era which could be called era of science, scientific age, if you so wish. Before, we had other eras like religion and so on, philosophy, but there's one interesting observation. I think I have to tell it in the computer. Yeah. One interesting observation that the great religions in this world, the Asiatic religions, for instance, they are about, all of them, about 2,500 years old. Our philosophy is the same age. Our religion, Europe, Christianity, is 2,000 years old. Islam is 1,400 years old. But science is less than 400 years old. And in these 400 years, it has changed the world more rapidly than anything before. So I would like to begin by trying to go with you through these 400 years, which have rapidly changed our world. The beginning of science, and there's no discussion about it, is in the 17th century. Now, I will also, of course, mention Galileo, Descartes, and Newton, but I think it is equally important to mention that the 17th century was one of the bloodiest centuries at all. It was a century of wars, and in particular of religious wars. There was the 30 Years' War between 1618 and 1684, and in the Duke from Württemberg, to give you just one example, before that war, the population was 400,000, and after the war, the population was 50,000. So in these 30 years, Europe was more devastated than in the Second World War. And I mention this because I don't want to say it is so, but it is a possibility at least that science originated because in these bloody times where people were killing each other, some intellectuals were longing for a method to find knowledge or even truth without bloodshed. And that was the great invention of science. Incidentally, I've written it up in the second half of the 17th century. There was another clash of religions. The Turks tried to conquer Europe, and they came up to my own hometown, Vienna, and in 1683 they besieged Vienna, and the Poles came to our rescue, and so the Turks had to go back. That's why, at least in those times, Europe stayed as it is now. Now, as I said, in this time, it was, first of all, Galileo Galilei, who wanted to, he never used the word truth for his science. He always focused knowledge about nature. Otherwise, he would have had troubles with the church. I mean, the trouble with the church, where everybody talks about the trial of Galileo, was not really a trouble with the church. It was just a trouble with the Pope, who was his friend before. And he was not accused of heresy, because it was important he never committed heresy. I tell you this because you read it differently almost everywhere. He was accused of disobedience, not of heresy. Okay, so I don't want to say more about it. It's not so important. Galileo in 1632, that was exactly the middle of the 30 Years' War, he wrote this book, Dialogue Concerning the Two Chief World Systems, in which he first developed the method of science, and his idea was essentially that if we want to achieve knowledge about nature, as he said, then the best way is to measure things and to make experiments. So he was the inventor of the experiment. He invented the experiment. If you wish, I can tell you in the discussion what exactly was the first experiment he did, but I have no time in my talk. At the same time, a contemporary of this was Descartes, Cartesius, the Frenchman. And he didn't have the method. Galileo talked about nova scienza, the new science. Descartes did not have the experiment with the method, but he wrote explicitly about the method. He distinguished, first of all, between in Italian, in Latin, res extensa in res cogita, matter and mind, or matter and spirit. He made this separation. And then he said there are 4 rules for good science. And 3 of them are sort of obvious, to be honest with you. But the second rule was equally important as the experiment of Galileo. Namely, he said that if you want to get knowledge about something, you have to divide it until you come to the smallest parts, and then look at the smallest parts, and from the smallest parts build up the whole thing again. So division into smallest parts. And then in the second half of the 17th century, the great Isaac Newton wrote his famous book about gravitation, Philosophia Naturalis Physika Mathematica, gravitation, and also the calculus, differential calculus, and so on. And these are 3 pillars on which scientific thinking rests. Because we all know what we all use scientific thinking in our daily approach to science. But not very often do we think about what is it, what we call scientific thinking. And it is a way of thinking which rests on 4 pillars. To the 3 pillars, I have told you now, comes the 4th one, and that's Aristotelian logic. What other cultures call the either-or thinking of the Westerners. That's Aristotelian logic, the axiom of the excluded middle or of the excluded third. In other words, if you have a contradiction, and it's a complete contradiction, then one side must be right, the other one is wrong. There's no middle and no third possibility. That is Aristotelian thinking. And these are the 4 pillars which I have just explained to you. Measure everything by Galileo, break everything to smaller pieces by Descartes, always either or by Aristotle, and always find a cause by Newton. This is what I call scientific thinking. If you allow me, I didn't intend to because of time, but now I have to tell you how I came upon this, because I think it's very interesting. I have in the 1977, I have devised, invented what we call, like Swedish colleague, the workshop on weak interactions and neutrinos, which is still going on with the international conference, the annual conference. And after a few times, it became international enough, so I organized it in Japan, because I was always wondering about Japan, because I have always heard that Japanese or Asiatic people think in a different way. And I always thought that's not possible, because either you think correctly or wrongly. See, either or. See? So I went there, and I asked my colleagues. Now, during daytime, we have to talk about neutrino physics, but in the evening, couldn't we get together and talk about Buddhistic thinking at that time? So there I would say East-Asiatic thinking, because it's not connected with Buddhism. And their answer put me on this track. The answer was yes, because Japanese are not allowed to say no, that was physical. So they said, yes, but. He said, yes, but we are not the right persons for this. Because we scientists have decided for European thinking. And that was a shock to me, because well, there are some people from Asia here, but the rest, who of you has ever decided to think in the Western way? You cannot do this in the West. I mean, either you think correctly or wrongly. So, that's why I became interested in what it really is. And here is my answer. Now, that was the 17th century. The 18th century is often called the century of enlightenment. And we are very proud of enlightenment in our culture. Correctly so. Incidentally, I would like to warn you, because I said I'm proud. Please don't misunderstand me. what I say is never meant in the sense of the evaluation of good or bad. Because I think that nothing in this world is either good or bad. Everything in this world has advantages and disadvantages. And the question should not be is it good or bad, but the question should be where do I accept the disadvantages because of the advantages? And that's a more difficult question. Because it can also be a personal judgment, different from person to person, so you have to reach agreement. But this, I never mean good or bad. So, because I just said enlightenment, a wonderful thing it is. But of course it has also its disadvantages. And very often enlightenment is thought of as the separation of science from religion. Now, if you look a little bit closer, it's not a separation from science and religion. It's a takeover from science of religion. And Voltaire, who was one of the great persons of the age of enlightenment, he wrote Maupertuis, the physicist Maupertuis, never mind. The physicist Maupertuis had explained to him Newton's theory. And in the beginning, Voltaire didn't understand it, so he had some questions. And then, on November 5th, 1732, he wrote to Voltaire a long letter in which he said, "Your first letter baptized me in the Newtonian religion. Your second gave me my confirmation. I thank you for your sacrament." It was quite clear that for Voltaire, science was a new religion, new kind of religion, as you can see. But the Enlightenment gave us, the century of Enlightenment gave us a few wonderful things. First of all, in 1776, the Declaration of Independence in the United States. And there you can read, men are created equal, and then in the text it's pronounced as liberty, and this is what we had in the French Revolution, as you can see, equality, liberty. But instead of fraternity, in America it says the right to pursue happiness. And this is the distinction. Very often the different cultures in the United States and Europe are traced back to this distinction in the very beginning. Because in the French Revolution, 1789, we had this liberté, égalité, fraternité. Liberty, equality, and fraternity. And some people say, I don't want to tell it to you, but some people say this has to do with the fact that in Europe, of course, the social security, health insurance and so on, was a big program because of fraternity service. Whereas in America, some people say, no, that's very bad. We have the right to pursue happiness and then take care of those who need it. Maybe in a more personal way than in Europe. So everything has advantages and disadvantages. I just realized that I don't have to go to this. You mentioned so many good things, but you didn't mention that I'm a theoretician. So, in 1775, in the middle of the century of Enlightenment, the French Academy of Science sort of took over the spiritual guidance of the world. And in 1775, they proclaimed it is impossible to obtain perpetual motion. And then they said from now on, the French Academy of Science will no longer answer letters with saying a perpetual motion machine. Now, to us, that seems sort of trivial thing, but it isn't, ladies and gentlemen, because in 1775, the word energy was not known to science. So the energy, the term energy, comes from the middle of the 19th century, and the law of conservation of was completely unknown. That is what found first by Robert Meyer, then by Joule, and then by Helmholtz. But Robert Meyer, to tell you two stories also, Robert Meyer was a doctor on a ship doctor. And he wrote an article about not the conservation of energy, because the word energy was not known to produce in those days, but conservation of force. In Helmholtz, who finally laid out the theory, he talked about the conservation of force, not Joule. Not Joule. His teacher, Kelvin, William Thomson, Lord Kelvin, he created the term energy. But still, we think this is a very great achievement of French Academy, even had the feeling sort of that this is possible without having the theoretical background. However, we have to be a little bit careful. In a sense, they took over the role of the church. They said what is possible and what is not possible, what is not true. But in our days, we only report the successes, which is a great success. But I will tell you also some other story. At about the same time, Lavoisier, he was the president of the French Academy of Science, and he was the founder of modern chemistry, chemistry, a big thing. And he proclaimed, it is impossible that stones fall from heaven. And as a result of that, which was a tremendous loss to science, because as a result, the big museums, like the British Museum, they threw out their collections of meteorites in the dustbin, because they thought this is esoteric, And it was the German, with an Italian name, but the German lawyer, Ernst Chladni, who was an amateur scientist, a very good amateur scientist. And he claimed that as a lawyer, opposed to some of the people in the academy, the academicians, as a lawyer, I can tell if somebody is right or is crazy. And he went to this place where people claimed that rocks don't fall from heaven. And they interrogated these people, and they said they are not all lying. And so he started a big fight with the academy. It was really a big fight, and this was usually not talked about. But the fight was solved by something which to me is almost the proof of God, because in the midst of the fight, just in front of Paris, in a small suburban of Paris, the greatest meteorite shower of all time came down. 3,000 meteorites. And that solved the problem. Sorry, I don't have to do that. So, science was not yet really on firm ground, but still. Now, the next century brought the first fruits of the scientific development, the Industrial Revolution. The Nobel laureate in economics, Robert Lucas Jr., said, for the first time in history, the living standards of the masses of ordinary people have begun to undergo sustained growth. So science brought living conditions and improved terms of living with lots of people. Now, let us recall the frame of thinking, which I call mechanistic thinking already, because the more fruits it has brought, this kind of thinking, the more exclusive it became. And people thought that only mechanistic thinking will be fruitful for mankind. So, for instance, in this center of the Industrial Revolution, Laplace, one of the very famous mathematicians and astronomers, he proclaimed his so-called démon. He proclaimed determinism, an intellect which at a certain moment would know all forces and all positions of all items for such a intellect, nothing would be uncertain. In other words, now we know, because of science, that everything is determined, and we cannot do anything about it. If there is such an intellect, the strange dichotomy now is, if you do not believe in God, then there cannot be such a demon, but if you believe in such a demon, then you believe in God, but you think that everything is determined. So you have I don't have to tell you that since quantum mechanics we know that it is principally impossible to know all the location, positions, and momenta of all bodies. But in those days it was contained, and this is of course possible because of this mechanistic thinking. Now, William Thomson, I mentioned him, he was the gentleman who created the term energy. He said, if I can make a mechanical model of the thing, I can understand it. And he even went on, I didn't write it, was too long. He said, if I can not make a mechanical model at every respect, I cannot understand it. So understanding became bound to the mechanical model. And I tell you, unfortunately, up to then, even the great Richard Feynman, Nobel laureate of the last century, he was really one of the greatest physicists ever. He said, quantum mechanics cannot be understood the way we would like, because he has no mechanical model. That he didn't say, but he simply said quantum mechanics cannot be understood the way we like. Okay, so this was the last industrial mechanistic thinking. Now comes the 20th century. Unfortunately, in the first part, there was devastation again. The world wars resulted in the two atomic bombs in Hiroshima and Nagasaki. And strangely again, it's a strange coincidence that at the same time it was one of the biggest steps in the development of science altogether. Albert Einstein had his Annus Mirabilis, 1905. In those days, he was Patentbeamter dritter Klasse, patent office, third class in Bern, because his teachers at the University of Zurich had told him he should give up science. He was much too confused instead to do science. We are very grateful for his confusion. So, in 1 year, 1905, he published 5 papers about 3 subjects, about relativity theory, particle wave duality, and the Brownian motion. 10 years later, he created the general relativity. He showed that Newton was only an approximation to gravitation, not the real thing. And in 1926, the group around Niche 4, including Werner Heisenberg, Jordan, and Bohm, and others, have created quantum mechanics, and independently from them, Erwin Schrödinger, you mentioned, and Wolfgang Pauli, the two Austrian contributors. I apologize to possibly these people here in the audience, because they think Pauli was sick, and Pauli was born in Vienna and went to school in Vienna. But from the year 8, from his age of 18, he went to Zurich and stayed there for the rest of his life. But this will claim him with our Nobel laureate. Erwin Schrödinger, he was my teacher in Vienna, and he came back to Vienna. They created quantum mechanics. I will have to say a word about that, because I had already anticipated that quantum mechanics goes across with mechanistic thinking. It's the end of mechanistic thinking, but it is not accepted to the day. I'll show you, and this makes me very sad, because I'm 77 now, and I have not so many years to teach, and I have put a lot of teaching physics teachers to try to get the mechanistic idea of the atom out of the school, but I have not succeeded. I don't ask here, but usually I ask the audience at this point, who of you has learned in school that the atom is something with a nucleus that the electrons go round? And I don't ask them. But normally at least half the people raise their hand. And it's completely wrong. Absolutely wrong. But they still talk. Because, why? Because it's the last possibility of mechanistic thinking. You see? So this is something incredible. So, let me tell you that Max Planck, Albert Einstein, Louis de Broglie, Max von Laue, and Erwin Schrödinger, 5 people who got the Nobel Prize for their contribution to quantum mechanics. After their contribution, they said, we don't go along because it is not mechanics. It's a very interesting thing. You know the famous phrase of Einstein, God doesn't go dice. So, second half of the 20th century, let us go over the first half down to possible. After the devastation of the first half, some unification idea came up. United Nations were founded, European Union in 89, the Cold War ended, and the idea of globalization came up. In science, the standard model of elementary particles, absolutely, but mechanistic thinking dominates. I've already told you. Now here it is again, mechanistic thinking. This is incidentally, since you were kind enough to mention that I'm also involved in complementary medicine. This is my contribution. I tell you, please do not think that you can understand the human being purely. That's all I tell them. It's hard enough. In some cases, it's very good, not good or bad. Advantages and disadvantages. In my case, for instance, 21 years ago, I was blind on the right eye because the retina had been cut completely. It was great. There was a surgery on purely mechanistic grounds, and now I can see with both eyes. So mechanistic thing is not bad, but it has some limits. Okay. So let us now try to. I put away my watch because I didn't want to take too much. And I put it here and I forget about it. Let us think for a moment what are the advantages and disadvantages. Because I said not good or bad, but what are the advantages of mechanistic thinking are, first of all, the possibility to make a checklist for all your actions. Yesterday evening I flew from Vienna to Leipzig, and there was absolutely no fear or nothing. I mean, you get into a plane, and it's just an obvious, ordinary thing. Now, think a moment, the security of flying in a plane must increase dramatically all the time, because the number of planes flying, the number of persons flying, increases dramatically all the time. If we would have the security in flying, which we had in 1960, and I've been flying then already, then every week the plane would go. And nobody would enter a plane anymore. So we have to really, it's a fantastic thing. And this is achieved by the general rule, most of you might know, that nothing may be done in the cockpit of the plane which is not written on a checklist. Everything is written on a checklist, and nothing else may be done. Even when something bad occurs, they have to pull out the checklist and look what they do. If you ask me some question, I have a big repertoire of cases of plane problems. Then, it's very interesting. In particular, if you read the last 10 minutes of the black box, the conversation in the cockpit, the last 10 minutes, this is something I can read only one or two traditions, but it's interesting. It shows you how powerful this method of technique can be. Now, another advantage is that mechanistic thinking is free from contradiction. The contradiction is always complex. You can always Aristotelian thinking is always either or. And it poses a hierarchical order. It's always known who knows better sort of hierarchy in the ideal case. This is the checklist that we an example. Now the disadvantages are there is no responsibility. Because everything, as I told you, in a bit only what is written on the checklist may be done. So there's no responsibility to these people. They have to be extremely careful to do the right thing. But it's not a matter of responsibility. I take the responsibility, but responsibility is objective. So that is a discipline, a personal involvement, personal activity. And that it is free from contradictions is also a disadvantage because it means that in the separation of Descartes, of mind and matter, of matter and spirit, we have reduced everything to matter because there are no contradictions. This is to forget what one is. Self-determination is not given because there is no responsibility. It's not human mind, it's matter mind. But let me give you a few examples how far it has gone, the mechanistic thinking. I've mentioned already the Scientific American, you all know this journal, Scientific American, is a very good journal. On October last year, they had an issue with the title, The Language of the Brain. And the headline of the issue said, how the world's most complicated machine processes and communicates information. The brain is considered as a machine, which has its advantages, but I'm not sure whether it can really. Even evolutionary biologists, these are quotations from original papers from researchers, talk about mechanism of evolution. Neuronal synchronization is mechanism, that's the brain of the machine. And in psychoanalysts talk about psychic mechanisms of integration. The last quotation is not from the scientific paper, it's from the internet. But I had to add it because it was so good. He said, God is not the supernatural force, but is instead a mechanism governing motivation. Okay? Look, God is a mechanism. And now, I have to tell you about the title I chose for this talk. Can we understand equality, freedom, and fraternity mechanistically? And in my opinion, no. Others may have different opinions. It's okay. I'm not against, I'm not in the mood of either or. But I tell you my approach and my personal opinion. But equality, freedom, and fraternity, I have said on one of these slides, are the basis for democracy. So if we cannot understand it mechanistically, we cannot understand democracy mechanistically. But democracy is a value which is, I'm particularly speaking to the younger colleagues in this room, which we should hold up as strong as possible. Because maybe in 200 years we will have something even better, but as long as we have to sort of even, I was almost going to say, fight for the idea of democracy. But if it cannot be understood mechanistically, then what else? And I'll give you my personal answer. Now, this is my personal answer. Equality does not make sense without difference. Freedom does not make sense without rules. And fraternity does not make sense without honor. So, there we have, you may say, either contradictions or, unfortunately, the beautiful word of Plato, aphoria, is no longer in our language, but that would be the right description. Aphoria is a Greek word, means no way out. So contradiction is a possibility, but maybe it's a hand-egg problem. And I have designed a model of thinking which takes into account this text. And I will present to you this model, and then you can make your own stuff. First of all, let me say that many people look at quantum mechanics because they say quantum mechanics, we have learned how to cope with contradictions. I mentioned before that exactly 100 years ago, Bohr designed his first mechanistic model. When Rutherford discovered that the atomic nucleus is 100,000 times smaller than the whole atom, he thought that the atom is something where the electrons go around like planets. And Bohr designed a mechanistic model in which he could work out some of the values, energy values, for instance. However, on the wrong assumption of angular momentum. So it is the Bohr model is physically wrong. The energy levels come out correctly, but the angular momentum is wrong. So it is definitely wrong, and also completely rubbish, because the atom is a sphere and not a plane. You know, the implicit structure. You know that from metal crystallization, for instance. So, as I told you that even today we talk on the other day I was checking through television because I didn't like what I saw, and I ended up with MTV, which is the German version of CNN, and they had very good programs about the universe and so on. And I followed it with interest because there were colleagues from American University talking until all of a sudden somebody started to explain that the atom is something and that the matter is essentially nothing. Only stupid. So I switched it off, you know. But it's incredible that a university professor would take this on TV, but okay. Quantum mechanics. Objects in the microscopic world are simultaneously discrete and continuous, particles and waves. This is why Schrödinger gave up. He said either or. So he said, I am for waves. Einstein said, I am for particles. And so on. And Max Planck said something which turned out to be true, unfortunately. He said, a new idea never gets success in the way that its enemies are persuaded, but always in the way that its enemies die. When the younger people grow up with a new idea, and he was right. This is a human thing. Okay. Now, this is what from scientific area, such a nice talk. I'll read you it, so we can read it. This guy tells his secretary, once and for all I want to know what I'm paying for. When the electric company tells me when the light is away for a party, I'll write my check. I have used this in my textbook of quantum mechanics on the context. That's why I have the right. So, but quantum physics cannot directly be applied to human problems. It has been tried since Niels Bohr and never succeeded. Because our problems are not those of uncertainty relations, but about freedom and self-determination. And elementary particles have freedom in a certain sense, but they are not self-determined. But they are determined by the laws of nature. So I have a different suggestion. I call it the HX model. And it has turned out to be very fruitful in economy, for instance, I'm now teaching at the University of Economy in my HX model because I find it useful in change management. Changes like things. So we have said equality leads difference. Equality without difference is identity. Still something else. Difference means unification, because difference without unification is separation. And we want neither identity nor separation. I call this the shadow. The shadow of equality is identity, and shadow of the difference is the separation. So I put them on the four sides of an age. Difference and knowledge of singular. Yeah, here it is. Difference and equality or unification, whatever you say. And separation is the shadow of difference, and identity is the shadow of equality. And the goal, the struggle, should be to find a balance between difference and equality without falling into the shadow. So the way to the goal would be to say, to attempt a difference without separation and equality without identity. However, I call this the HX confusion. Instead of the H, we have the X, which means that those who are different, they fight identity. And those who are more for equality, they fight separation. And we have a fight in which both sides are right. That's the tragic thing. Because we want neither separation nor identity. So both sides are right. And this fight can go on as long as it is. And it would even be bad if one side would win. Because if one side wins, for instance, then we have, then they agree we don't need identity, but then instead of difference we have separation. And if the other side wins, instead of equality we have identity. They fall in to the shadow. And the solution is that both sides acknowledge, they discover that they are fighting the wrong enemy, the wrong shadow. The enemy of difference is not identity. The enemy of difference is separation. And the enemy of equality is not separation, the enemy of equality is identity. If both sides recognize this and begin to fight their own shadow, then we have reached harmony. That is the goal. But it is very, very difficult. So next, that was equality. Yeah, examples. The outsider problem. The gender problem, complementary medicine, globalization, the culture difference. You see? People very often, for instance, in the gender problem, you can see it very clearly. You have two parties. The one say, there's absolutely no difference, absolute equality. And the other side says, no, it's total difference. Let's stick to our side. No? And as long as this fight goes on, we are still keeping the HX confusion. No? Then we cannot achieve agreement until this is recognized. So, freedom, next. Freedom needs rules. Freedom without rules is anarchy or arbitrary. My freedom to accept your kind invitation to give this talk here rests on the fact that Lufthansa and Austrian Airlines have a strict order. So I know that I can sign up. You see, it's very simple. But the traffic rules, those are simple things. You know? But when it comes to more difficult, like we see now in Turkey, for instance, then, or we have seen in North Africa. Then it is what it is. I have to apologize for this one. Order needs freedom, but this is a mistake. That should say order without freedom is order without freedom. You will see on the next order without freedom is control or tyranny. Here it is right on the previous. Unfortunately, I've written the wrong sentence. Okay. So freedom. Freedom without order becomes arbitrariness or anarchy. Order without freedom becomes control or tyranny. And in the 8x conclusion, the freedom fighters fight against tyranny or control, and those who are for order, in the sense of arrangement. Ordnung, nicht Befehl. Order is in English has two meanings. When they fight arbitrariness, then they cannot come to an agreement until they realize that the enemy of freedom is arbitrariness or anarchy, and the enemy of order is control or tyranny, not the other one. Fraternity. Fraternity needs sense for community. Fraternity without sense for community is egoism. Sense for community means self-determination. Sense for community without self-determination is altruism. So we have again this age situation. Self-determination is very good. It does not fall into the shadow of egoism. And sense for community is very good as long as it does not fall into the trap or into the shadow of altruism. If we acknowledge this and if we reach the balance, the harmony between self-determination and sense for community, then we call it love. In this general sense. And again we have this 8x conclusion. But fraternity is a more complicated thing, so I have two more, and then I have two more aids. Because fraternity also means tolerance. And tolerance needs conflict. That sounds strangely difficult in our time, because we are so deep in the age conclusion. Tolerance needs conflict, because tolerance without conflict is apathy. Maybe you remember when some time ago in Holland, in the Netherlands, there was a gruesome murder by anarchist, and he was dead to death. And all the newspapers wrote, we have confused tolerance with apathy. Wir haben Toleranz mit Gleichgültigkeit verwechselt. So we need the conflict. But conflict needs tolerance. Needs tolerance. Conflict without tolerance is quarrel. It's brutal fight. And we won't marry. So we have this age. If we can achieve tolerance without apathy and conflict without quarrel, then we can have harmony. And we have to overcome the 8x conclusion. And if we can do this, I call this active tolerance. Tolerance has to be active. Not just say, I accept you. Do whatever you wish, I don't care. That's not tolerance. It's active. And finally, when we now talk of globalization, which may be the goal towards which we are developing our society, we can say unity needs diversity. Unity without diversity is uniformity. And diversity needs unity, because diversity without unity is arbitrariness. Think of the European Union. The European Union is a fantastic development in my mind. I'm very happy to live in a time where such an undertaking on the large scale is going on. What they're doing, in my interpretation, they try to overcome the apex confusion. But it is a hard struggle. You know, I mean, this struggle, what should be decided in Brussels and what should be decided outside and so on. This is a hard political struggle because we don't know ahead. We cannot do calculation how much is right or not. We have to go through this. Right. So we have unity and diversity. We have this unity does not degenerate into uniformity, like everything is decided in Brussels. And diversity, we should see that it does not degenerate into arbitrary and truth. So this is a conclusion, and this is my latest book. That's the end of my talk. Thank you.
We are very pleased to listen to this lecture, but you were not only
Brauche ich keine Sprache, aber die
allowed to
Übersetzung halt lese einfach das Buch.
now you are also invited to discuss. So please let us have your comments, your questions, your opinions. The Pitchman will try to answer all of your questions. So go ahead, don't be shy.
Hello? My question is a bit about history. You said that science started like 400 years ago, and its first results were seen like 200 years later. Like, it's a short time for the whole history of the population of people. So my question is, what were the reasons before that didn't let the science develop like many years before that, 600 years ago?
That it took so long.
Yeah, why it took so long, and what were the barriers, and how people at that time overcame that.
Can I answer this at length? It's a very important question. You see, I told you that the great religion in Asia, as well as the European philosophy, were created at the same time. Karl Jakob calls this the action time, the action time, the whole mankind rotated around the action. A really big change in mankind from the age of myth to the age of logic. And this was all over the world at the same time. You know? And Plato, Aristotle, Siddhartha Gautama, the Buddha, Confucius, Lao Tse, and the Persian Zoroaster, and the great the Old Testament. They all lived at the same time. So this was really a fantastic thing. So then the question is, why is it just in Europe that new development comes in? And of course I don't have the final answer. It's too big a question, but I'll give you some hints. First of all, what one did before, until that time, was one tried to explain the earth as it is. For instance, Aristotle has not only written a logic, but he has written a big book called Physics. There was a physics. But in his physics, he describes the world as we experience it. For instance, he says that the heavy bodies fall fast, light bodies fall slowly, and fire-like bodies like smoke don't even fall, they get up. And he has some explanation with the four elements. And he says, for instance, he even had a law of motion. You know, Newton's law, that the force is proportional to the acceleration. But Aristotle said the force is proportional to the velocity. And he was right, because in those days, there were no force cars with a big acceleration. Acceleration didn't play a lot of role, you know. But if you pull a car, you want to pull it twice as fast, you have to pull twice as hard because of the friction. Newton's law is only valid without friction, whereas Aristotelian law is only valid in the time where there is no big acceleration. So the description of the world, also in Asia, gives us some feeling, some insight into the world. Now, the big step of Galileo was the following. It turned out, in the century before, the 16th century, it turned out that our calendar was wrong. The calendar we used was going back to Caesar, and it was wrong by 10 days compared to nature. Therefore, there were plants were not sown and harvested at the right time, and it was very bad. So people noticed it. And then the church noticed that the holy festivals like Pfingsten, and Easter were not celebrated at the right time, 10 days old. So then they had to correct it. And that was only in Europe that the church sort of had a hierarchical position and could say, now we have to do something. And what they did, they said, in order to design a new calendar, you know that people of Caesar, they knew that the year has 365 plus 1 quarter day. That they knew. So every 4th year you have to have an extra day. Now, 97. That they knew already. So, but what they did not know, that every 100 years you have to fix this day. That they did not know. So the correction had to be in the 30th decimal. 365, point, and in the 3rd decimal. So it was a very fine, delicate correction. And that could not be done on the basis of the Aristotelian polyveic spin, with the earth in the center. It simply couldn't be done. So what the church did, they said, let's try to assume that the sun is in the center. And the earth and all the planets go around the sun, except for the moon which goes around the earth. So that we can get a new calendar. That was done by the church. But then they had troubles because this had, after all, this is only for the matter of calculating the new calendar. It's not true. It's not true. We only use it for calculating the calendar, they say. And the truth is that the earth is in the middle and the sun goes, all the planets go around the earth. But for computing the calendar, we have to make a hypothesis, is what they say, and the hypothesis is not true, but useful. And Galileo came up and said, I do not want that the bright gentlemen in the future have the opinion of me that I have accepted the Copernican system as a mere hypothesis which is not really true. But then, of course, he was in difficulties because he could not say the church is wrong. Because if he had said that, would have been very healthy for him. But he could also not accept that a later generation would say that Galilei fell into this church. So he said, I have to devise something new. In the next church. And what he did was, he said, he had discovered the phases of the Venus, moon phases, full moon and so on. And if you look with a camera, then you see also the phases of the Venus. And he said, I calculate the way the phases of the Venus will change according to Copernicus and according to Galileo. And then I check and look, Copernicus is right and Galileo is wrong. So he said, I don't say it's true, but I say the experiment tells me, and that was the beginning of the birth of science. So it was really a singular case, and the great Carl Friedrich von Weizsäcker, who was a friend of mine, who was also a philosopher and a physicist, and we were very close. And he has written many books, and in one of his books he said, let me first say this in German because I want to quote it correctly, and then I'll translate it. He said, Galilei erzielte seine Erfolge, weil er es wagte, die Welt so zu beschneiden, wie wir sie nicht erfahren. Dafür aber mathematisch einfach. He said, Galileo had his success because he dared to describe the world in a way which we do not experience, but in a mathematically simple form. And this is true. I mean, the first physics law was the law of Galileo that all bodies fall with equally fast, which is not true. In fact, I don't have to do it, but if I let these two things stop, this will be fast and this will be slow. I'll show you what's right. Galileo describes the world not as we experience it, but the world without air resistance. Kepler, also a contemporary, he had his first law saying that the orbits of planets are ellipses, and in one focus there is the sun. Now I tell you, with the authority of an old theoretical physicist, in the entire universe there's not a single planetary orbit which is an ellipse. So this Kepler's law is simply wrong in the world in which we live. Because Kepler's law is true only if there is one sun and one planet and nothing else in the whole universe, and if the sun and the planet are totally spherical symmetric. So even the Himalaya already, So, and this is the new way, a real invention, that we first go to simple things, as Descartes had said, and leave out everything, and then step by step we approach the world in which we live. And now we can send, today we can send probes through the whole planetary system, and because we have the full equations and the transmission rules can go step by step as geography. This is why it was a solitary thing in Europe. I hope this is a short answer.
Just one more time for a question, go ahead. Warten wir eine Sekunde, nachdem Sie es vielleicht eingeschaltet haben, dann könnte es jetzt gehen. Ja, doch, wir hören Sie.
Okay. Thank you, Mr. Fischmann, for your very interesting lecture. And I have a question. You're talking about equality and identity and order. And at the moment we have a very strong economic quest for efficiency, which has a very strong uniform character. Efficiency tries to make everything equal, to process it efficiently and to make economy more smoothly. And I'm a software developer, and the somewhat perverse dream of software is only one word database and only one word software system. That would be the most efficient system of the world. And have you ever taken those thoughts about economic efficiency into your considerations?
Unfortunately not. The reason is simply that I don't understand enough of economy. And I don't want to be just on the surface. But I can say that I absolutely agree with you that this is personal agreement, that this is one of the very, very important questions of our time. If we are not able to solve this question, then it may be very bad for the future. But unfortunately, I don't understand enough of economy. Thank you.
Just wait for the microphone a second, please.
you very much.
Yeah, it's okay.
Thank you very much for this very interesting presentation. I have two questions. One more simple. You were pointing out that you don't want to tell about the truth, because the truth is a property of the church, of the religion. So we are striving for the knowledge. What makes a difference? Then I remember this young man before who is dealing with information technology. What is the difference between knowledge and information from your philosophical point of view?
Thank you very much for the question. Unfortunately, it's again such a substantial question that my answer may not be very short. You see, that before we can talk about the distinction between truth and knowledge, we have to take up one distinction which was with us since 2000, more than 2,000 years, but has been forgotten, unfortunately, lately. That is the distinction between richtig und wahr, correct and true. This is something definitely different. You know, so I don't have to go into the details. I'm equally disturbed by the fact that I told you that atomic model is built on, by the fact that in mathematics book it is always talked about truth. 2 times 2 is 4, it's not true, it's correct. And that is this difference is very important, because something which is correct independently of your own personal view. Whereas truth requests the personal agreement of a human being. Something is true only because at least one human being thinks it is true. No, I always say, for instance, if the archaeologists dig out an old culture and they find, by some means, they find their religion, this old culture which is died out, then there's no point in asking whether this is true, because nobody believes in it anymore, so it's simply historic concept. So truth requires personal acceptance of it. So my typical examples are always mathematical statements is correct, and truth statements, religious statements. If nobody believes in it, then there's no point in talking about truth. And on the personal level, also, excuse me, I always have this example. If somebody tells me, I love you, and I answer, can you prove it? I have not understood what she means, See, that sentence does not require proof, but it requires that I stand behind it, And the miracle of science is that it has created a third element in this distinction between correct and true, and this is knowledge. Because we cannot prove the laws of physics. Karl Popper has pointed it out so clearly. We can only disprove wrong statements, but that doesn't mean that we can falsify theories, but we cannot prove the theories. But still, we can act upon them as if they were true. My example is always. Suppose I told you that I have lots of examples of plane crashes. That's fine. But this is always my example to explain this. If a plane crashes, then there's a committee looking for the cause. And they have to find the cause in order to avoid another similar accident. And they have to be very creative in finding the cause. My example is always in the 60s, until the 1960s, it was absolutely unthinkable that the passenger would go on board the plane with an explosive and blow the plane. Nobody could think of that. in those days, I remember very well when there were not too many passengers, the captain would say, if one of you is interested, come to the cockpit, and it's completely unthinkable. And then it was in the 60s, around the mid-60s, when the first person was desperate in financial grounds, and he made a very, very big insurance and flew up the plane. And the commission found it out, because for some reason there was one seat in row was very far from the rest of the debris. And then they started thinking, how come that it was so certain? And so they found it out. So they have to be very creative. Everything which is possible they have to come to think about. With one exception, this is the central point. If one of the members of the committee suggests that maybe on that day and that place the Bernoulli law about the wings and so on did not work, then his colleagues would say, now you go on leave because you need it. So which means that what we call sensible thinking, vernünftiges Denken, rests on the ground that the knowledge which we have gained by science is absolute trustworthy. Also we cannot prove it. So this is the third category. And this is my distinction. And I did not answer your particular question of information on purpose, again, because I haven't talked long enough about this.
Maybe my second question, I was surprised that you haven't used one tool. I think that is already in this image we can see here. Let's see, the world in particles and the world of a whole. So our world is not perfect. We have a kind of chaotic entity. So it's imperfect and we have a limited knowledge. So what about the term or the tool probability or doubts?
Yeah, that's again a very interesting question. So I'm trying to be sure. Sure. Now, the term doubt is on the basis of science. You always have to doubt until you cannot doubt anymore. And this is very often, I mean, in my lifetime, I have experienced this in particle physics quite often. Like most recently, the Higgs particle, and you have to doubt the theory, or so you use it, until you are forced by experiment. So doubt is an extremely important thing. But probability, I don't think so is important, because once the law is established, you could calculate some sort of probability, but I don't think it would represent the scientific thought properly, because once that is established, it's 100%. Until it is maybe it is proved. There are examples in the history. I could give very clear examples, but in the general trend, I think, I know that many people say, for instance, we cannot prove the laws of science, but they are proved with an extremely high probability. I don't think this describes properly what is going on in science, because, as I said, once we are convinced that we cannot falsify a theory, then we take it with 100% security. And there is this, among particle physicists, there is this saying, just joyful saying, but it describes the situation. Yesterday's discovery is today's effect and tomorrow's background. You know? And, but there are examples where I've looked, probably not time.
Any more questions, comments?
for me, thank you for your lecture. I have more comment than a question, and it's more related, well, not to the main topic. You said you would delete the model of atomic, from the Bohr's atomic model, from the schedule in schools. Actually, from the point of teaching, I don't understand that. Because how do we learn? We have two facts, we compare them. And just because of the difference, we understand and we remember things. So I think the new theory, or the real one, as you would say, we wouldn't have it if Bohr has made this experience with the Bohr model. So unless we don't know where we're coming from, we don't know where we are now and where we are going to. So from the point of teaching, I don't understand this maybe view.
Yeah. Okay, I accept your opinion, but let me counter it. If it were taught in the sense you wish, I would have no objection. So I wrote in my textbook on quantum mechanics, in particular for teachers. And I said, if you cannot go on to explain the quantum mechanical model, then you should not teach the Bohr model. Okay, so it is the same opinion. Yeah.
Okay, ladies and gentlemen, I think it's time to say thank you, Professor Pietschmann, because we have to say thank you very much. Ilmenau surroundings, not to forget us. We won't forget you. Thank you very much.
I will not forget.
Ladies and gentlemen, I want to invite you to a second highlight of this year's Academicus right after this ceremony. In about 15 minutes at 5 p.m. we will have the ceremonial unveiling of Newton's apple tree. I guess you know about the legend, or is it the truth about the apple tree? Well, every school kid knows about this anecdote. The apple tree should have fallen on the brilliant head of the famous physician Isaac Newton, and by doing this, ironically, it should have brought him to the idea of the law of gravity, of the immortal law of gravity. So the Technische Universität Ilmenau was given as a gift an offshoot of the most important apple tree in the world, or maybe the second most important after Adam and Eve's tree, I don't know. This gift was given to us by the dignified National Physical Laboratory in Great Britain. We say thank you very much for it. And we did find a worthy place to put it, to plant it on our campus. It is opposite of this building, so you're invited to follow us just in a second. It's planted just opposite of the building which is given its name, the Newton Bar. We would so like to invite you to this ceremonial unveiling. Please follow us in a minute, and at the end of this festive event of the Dies Academicus, we will listen to the performance of the children's choir of the music school Anstatt Ilmenau under the direction of Reinhard Tröps. Of course, they will sing us the Apple song. Thank you very much.